just a controlling activity that is happening. Sorry. Okay, so yeah, so let's see what we can try and do over here. I have drawn here a really crude diagram, okay, which would just show you how a loop looks like. Okay, see, this is a pipe through which some liquid is flowing. This is your transmitter. This is your transmitter, and from here this would transmit the flow rate that is happening in the pipe. So this is transmitted to your controller over here. Okay, it is transmitted to your controller. Controller would calculate your the value by which your valve has to be controlled. So from the controller it is transmitted back to your valve and it would regulate it. Now somebody has to give it a set value, right? So that set value to the controller would be given from the operating station over here. Can you see this desktop that I've drawn? Okay, from here somebody would indicate to the controller that this is the particular set point value I need. Maybe for a one-time activity he'll do this, but generally if there is a preset value of control, let's say a pipe always has to flow at, the liquid that's flowing through the pipe always has to flow at 5 liters per second or 20 liters per second, something like that, then that value would be fed to the controller. Controller itself would take care of it. Any overriding, any status checking, monitoring, all these things would be done by an operator or an engineer, and he has the control to this controller. This is just one controller. Similarly, you can have one more and another. Now one controller itself will be taking care of multiple loops. This is just one loop that I've shown. It can take care of other loops. Similarly, the other controllers can also take care of other loops. Okay, this is just a very raw diagram. I mean, it's not possible to just get into it. You have to touch every corners. You can't it just expands like this. So there are a lot of things to be explained. We just made a start. Okay, so now we'll have a serious look into. See, so far I have been calling it a box, right? One controller, I have been calling it a box. What is present in this box? Okay, let's have a look into it. Fine. Now, fine. Can you see this diagram? This one? Okay. This is the box that I have been talking about. So let's have a practical perspective. What should this box contain? The box is doing some amount of computation, right? When an input variable comes, it has to calculate, give an output value. This looks very similar to your computer, the processor. So there should be a processor. Something should power this processor. So you need power. Now, there should be a receptor which takes up the input signals that comes from the field, okay? And there should be something which disperses the control signals to your output, that is to your motor or whatever. Fine. So I would call them input and output cards. Fine. Input and output cards are required because see, the value that comes from the field is very raw. Sometimes it has to be conditioned. Sometimes you might want voltages in the range of 1 to 5 or let's say 4 to 20 milliamps, things like that. Conditioning of the signal is required. I would say my IO card would, that is input and output card, would do all these conditionings for me. So I have just divided this block into power, control, that is control, and the remaining space for placement of IO cards. This is the most basic diagram. Now we'll elaborate on this. Okay. Now see, controlling is not a joke. It is very critical. Sometimes the criticality extends to a level wherein failure for even milliseconds is not tolerated. That would be a bit exaggerating. Failure for second is also not tolerated. Technically speaking, it is said that you are not supposed to exceed a delay of 256 milliseconds in computation. So taking care of all these requires us to have redundant units. One power supply, if it fails, the unit fails. So I'll give it two power supplies. One computation processor card, I'll call it a CP card henceforth, okay? Control process card, for example. So I'll call it a CP card. One CP card fails, the computation doesn't happen. So I'll have two, CP cards. Okay, we'll just limit redundancy to this much. So what will change in this diagram? See, if you notice, I've made power into two. So there are two power supply units now. Control process, again two. See, power 2 and control process 2. So there are two CP cards now, two power units, and rest IO cards. Redundancy is also present over there, but for basic understanding, let's just limit to power and control process. And yeah, so this is how redundancy is brought about. So we do take care of all these minor things so that the control activity happens always throughout 24/7.